Question number 14 of the PhilNITS FE afternoon portion of the exam. In this question, we are given a function called calcsim that takes two vectors, which are arrays, as input, calculates their similarity, and returns a value that characterizes the similarity. A large similarity indicates that the vectors are similar, and a small similarity indicates that the vectors are dissimilar. For example, to quantify the similarity between two documents, you can create a vector of occurrences of some words for each of the two documents and input them into calcsim. When the function calcsim with the two vectors is called, the return value rounded to the first decimal place is blank. From this description, we can understand that we are gonna work on a calcsim function that checks for similarity between two vectors. I think to better understand this, let's look at the program. Here we can see that the function calcsim takes in two vectors, the two arguments, and we need to do some type of computation to figure out if they are similar or not. And from there, we should be able to choose the output when we reach the return statement here. This question actually, I think when I was doing it, it was difficult, but once you figure out what to do in this case, for example, this part, it seemed very clear now. You simply plug in the values. However, once I reached the part where you got the square root, I think that's where I made a mistake. And I ended up choosing letter J, which is incorrect because the correct answer is supposed to be letter I. Now let's see what's going on here and also attempt to explain why I chose the incorrect answer, especially once I reached the part where you got the square root. If the two vectors are these and we need to compare their elements, it says here that we need to go through each from 1 to the number of elements. And we are gonna do some computations. By the way, this one here can be a bit difficult to distinguish, so just take note that this is supposed to mean multiplication. It looks kind of like the X here, but smaller. Just take note of that. And if you go to the right side here, I put already the values if we adhere to the rules. The rules here where we got the computations. Therefore, if we line up the vectors in this way, as you can see, it's the same as this one. Will we be able to solve the problem? Given the rules, what we need to do for this one, the first row, SXX, we need to multiply the values of x. And we know that the value of x is vi at a given position. In this case, we start off first with the first position. Multiply that, therefore 2 times 2 gives us 4. The next one gives us 2 again, so that's 4. 1 times 1 is 1, 0 times 0 is 0, 4 times 4 is 16, and afterwards we will need to add all of them up. That's why we'll get 25. This is 4, 20, 4, 1, 5, so 25. Now for SYY, we need to multiply y and y. So that's why we have 3 here, and that's why we get 3 times 3 is 9. 1 times 1 is 1. 1 times 1 is 1. 1 again for this, 1, and then 2 times 2 is 4. Then we need to add them up. That's why we'll get 9, 1, 10, 12, 4, and that's where we get 16 here. Is that right? 9, 10, 12, and then 4, so 16. So this is supposed to be 16. I think the one here didn't display well. Okay, now the next one, here we have SXY, where what we need to do is multiply x and y. That's why we have 2 times 3 gives us 6, 2 times 1 gives us 2, 1 times 1 gives us 1, 0 times 1 gives us 0, 4 times 2 gives us 8, and if we add them up, we get 2, 8, 10, 6, 1, 7, add them all up, we get 17. Okay, so we've done this part, and I think when I was doing this and I saw that I think this is a number that I could solve, I think I was well, pretty glad that it wasn't too difficult after all. Of course, later on we will need to do the square root, and that's where I think I got the problem, where eventually I ended up choosing the incorrect answer. Now it says here that we have to do this sxy, which is this one, divided by the square root of sxx multiplied by syy. So if we are to write that down, we have the square root here, and then we have to divide this, which means, for example, 5 divided by 2 would be written like this: 5 divided by 2, because we want to know how many 2's are in the 5. Okay, so it has to be in this format: sxy divided by square root of sxx times syy. Okay, now the mistake that I did was, I think I focused on the square root, and then that's what I put inside the drawing here where you got the lines. So it was supposed to be in this way, but the square root was inside this and 17 was outside. That's why we have something like this. However, I think too that the fact that there's a square root here also contributed to the way I thought, because I remember that usually if you have square roots, you better use a calculator. But in this case, I think that if we plug in the values for sxx and syy, we have 25 times 16. And I think that at the time, I was also wondering if I can just do a 5 times 4 here. And then, why do I get 5 times 4? Because 25, square root of 25 is 5, right? Why do we get 25? why do we get 5 when we square 25? Because 5 times 5 is 25. And square root is supposed to be, for example, in this case, how do you get 25 if you are to come up with a number that multiplies itself? So in this case, we know that 5 squared, or 5 times 5, gets us 25. And 16, we know, is 4 times 4. So the square root of 16 gives us 4. That's why we get 5 times 4 here. But I wasn't too sure, so I thought that, okay, maybe I should multiply them first and then do a square root. So that's why I have something like this, where I did the multiplication and ended up with 400. And then when I had to do a square root, I thought that this might be too difficult to do. But because I saw the pattern here with the 25 and the 16, I thought, okay, so let's see if we can get something out of the 5 times 4. And if we do the multiplication, 5 times 4 gives us 20, right? And if we think about doing a 20 times 20, or 20 squared, we should get 402. So that means that doing a square root first for 25 and then 16 and then multiplying them is the same as doing a multiplication first, 25 times 16, and then a square root. So I think that idea, that concept, is something that we should have known beforehand, that we have learned previously in school, except that in my case, I guess it's been a long time since I did something like that, because like I said a while ago, usually if you're dealing with square roots, you better take out your calculator and just let the calculator do the computation for you. So I think that part, which used up quite a lot of my time and thinking process, uh, because of that, I didn't quite look well on the equation where we have the sxx or sxy divided by square root of sxx times syy. So in the end, what I did was I got the square root here inside and then the 17 outside, and then I divided them, which is how I got 1 times 1 1.1, which is actually I think in this case would continuously get us ones even after the first one. And that's when I looked at the part where you got the rounding. It says here that the return value has to be rounded to the first decimal place. The thing is, I also had problems with the first decimal place, because I thought that, for example, if this is the first decimal place, then we should get 1.0, right? But in fact, the first decimal place is this one, and if I had 1 here, then it would be 1.1. 1.1 would be the answer. And if we look at the answer group, actually there's no 1.1 here. So I think that a series of mistakes and a portion or 2 portions, I guess, this one and this one, that used up my thinking ability much more than the usual, I guess, caused the error in getting the right answer. Later on, I looked at the correct answer, which is I, and attempted to figure out where I got it wrong. And that's when I saw that really if you got the SXY divided by this part, it should be written in this way. And so if we did the division, we should get something like this. Because 17 is less than 20, we need to add a 0 here. And of course, for doing that, we need to put a point here, decimal point already. And 170 is already large enough for 20, and so we need to ask how many 20s are there in 170. And actually, I was looking at whether it should be 9 because it seems like 9 is the correct answer, but we know that it's beyond 170. 9 times 20 is 180. And so I needed to get the one prior, which is 8. And 8 times 2 is 8 times 2 is 16. Because we have 0 here, 8 times 20, 160. And when we subtract these two, 170 minus 160 gives us 10. And then if we get another 0, that's 100. And how many 20s are there? 100. We know that there are 5 20s in 100. That's why we have 0.85. And the part about rounding the first decimal place, which is this one, because 5 is the one next to it, the one after it, then this should be 9. So 0.9 would be the correct answer. And again, the answer group says that 0.9 is letter I.